So welcome you all again to the channel. So here up to last class we have learned about the formation of ionic bond like NaCl or ionic compounds NaCl, MgCl2, calcium oxide. Okay, so today like in a we'll see how covalent compounds are formed, right? How they are basically sharing their electrons, right? So if you see the covalent compound like hydrogen molecule, oxygen molecule, nitrogen molecule, carbon dioxide molecule, right? And most importantly water molecule, right? So we'll see how they are forming. So basically if you see, for the formation of hydrogen molecule, the hydrogen atom redistribute their electrons so that each combining atom attains a stable electronic configuration of the nearest noble gas, right? So everyone's tendency to get the configuration like nearest noble gas, that is what we are learning every day, right? Up to this chemical bonding chapter, all about these things only. The elements having some like particular electronic configuration, they has to either donate or has to either accept, or in case of covalent bonding they has to share their electrons. But ultimate goal is to attain stability by getting the configuration like noble gas, right? So noble gas means, like, again if I am recapitulating the things, noble gas like helium, okay, helium, neon, argon, right? These are the noble gases: xenon, radon, krypton. So those are the noble gases. So these three are important here, okay? Helium has 2 electron, neon has total 10 electron. So 10, among the 10 electron, 2 electron it will be in the first orbital, then in the next one it will be 8. So the configuration is 2 8. In case of argon, this is 2 8 and 8, right? So every time we have to find out that the element whatever we are going to use, where is the nearest noble gas. This is the main thing we have to think. Okay, then we can understand, okay, it has to donate or it has to accept the electron. That one we have to find out. And in case of covalent bonding, that time we have to think that if it is basically sharing their electron, is it really getting the stability or not, right? Is it really getting the configuration like noble gas or not? That is what we will see. Okay, so if you see the formation of hydrogen molecule, hydrogen, the atomic number is 1, so that means it has 1 electron, right? 1 electron. Now the nearest noble gas of hydrogen is helium, and you know helium has 2 electron, right? That is what we know already. Helium has 2 electron. So if hydrogen wants to become stable, it has to have 2 electron, right? Then what it can do, what it can do is that 2 hydrogen element, okay, this is one, this is another one. They came together and then discussed, and they finally agree one bond. Okay, that bond is basically the chemical bond. They agree one thing. Let's say two friend came together, okay, and they found that something it was selling in the market of 2 rupees, but this hydrogen, this is one people having only 1 rupees, okay. Another hydrogen that also has 1 rupees. So the seller already told them, you can't get the product if you have 1 rupees. So what, you have to bring 2 rupees from somewhere, okay. Then these two friend, the hydrogen 1 and this hydrogen 2, they came together and they discussed among themselves and they agreed, okay, I am giving you 1 rupees, you also give your 1 rupees. By this we will have a 2 rupees together total, okay. Then that with that 2 rupees we can buy that product, okay. That is what. So this same thing is happening in here also. If you see, let's say, okay, this is the hydrogen atom having 1 electron, the another hydrogen atom having 1 electron. Now what happening is that this electron, they are basically combining, okay. That means that and whatever that product they are going to buy, that thing they both can use, okay. The agreement was like that. The ionic compound, in case of ionic compound, what happening, one people is donating, another people is accepting, right? In that case, the other people who is the non-metal, that is basically that people does not have the electron at all, so means that does not have, so he is getting the donation, In this case it's not like that, it's basically sharing their electron to get that particular property, to get that particular you can say bonding or something, right? So that is what happening here, you see. Then this hydrogen, it is now like this. For that another hydrogen case also it is now like this. Now you see all the hydrogen having 2 electron total, right? Then they will form a bond like this, right? This is what bonding, and this is called single covalent bond, right? So this bond can have 1 or 2 or 3, in some cases 3 also, right? In case of oxygen you will see it is 2. This is called covalent bond, and the number, what are the number of this line, then according to that we will decide this is single covalent bond, this is double covalent bond, or this is triple covalent bond. Okay, so this is called covalent bond. Okay, so and the compound is called covalent compound. This is how hydrogen molecule it is formed. Hydrogen molecule, which is without hydrogen we can't form water also, right? So now we understood how hydrogen is formed. Now we are coming for the formation of the chlorine, right? Chlorine, Cl2, chlorine. So chlorine, how it will form, and what you know, how many electron chlorine has? Total 17 electron it has. The configuration is 2, 8 and 7, right? So chlorine need 1 electron. In case of ionic bond formation in the NaCl, that time what we saw is that sodium was donating the electron to the chlorine. Okay, by this way chlorine was getting 1 electron in their outermost orbital. By that way it got stability. But here in this case there is no sodium, there is no metal. Okay, here in this case 2 chlorine atom came closer, and they found that they need only 1 electron to get the stability, right? Okay, then this they thought, okay, then we can have a sharing of electron, is not it? So what they did is that basically they will share their 1 electron. If you see this chlorine atom, 1 2 3 4 5 6 and 7. Okay, in this case also 1 2 3 4 5 6 and 7. Now what will happen, they will share their electron like this way. Okay, now what they're forming is that like that. This is the chlorine atom. Okay, 1 2 3 4 5 6 7, and this is the another chlorine atom, 1 2 3 4 5 6 and 7. Now you see, now what will happen, they will basically share their electron. Okay, this chlorine is sharing this another electron, and for the other case also like that. If you now you see in the all these two cases, the number of the total electron is 8 only, means this circle having 8 electron, this circle having 8 electron, right? So now they fulfill their like whatever they need, right? They need 1 electron, they fulfill that one chlorine is helping another chlorine. By this way they form the bond. Okay, as here 2 electron is forming 1 bond, that is why this is called single covalent bond. The covalent bond you have to show like this way. This is how single covalent bond it is formed. Now we'll see for these things. Okay, now oxygen. So oxygen has how many electron? 8 electron. So 2 and 6 is the configuration. So oxygen need 2 electron. Okay, then similarly here also another oxygen element came, and that also asked this oxygen, okay, I am giving my 2 electron, you also provide your 2 electron. By this way we have a agreement, and that final that electron pairs will use both. Okay, so this way you can do like that. They have agreed with this 1 2 3 4 and 5 6. In the other case also 1 2 3 4 and 5 6. Now how they are forming, if we so like 1 2 3 4 5 and 6. Okay, for the other cases also 2 3 4 and here 5 6. Now what they're doing is that they are basically sharing their electron. See here you have to notice that how many total electron is getting shared, right? Total 4 electron. So this is basically 2 electron pair, or we can say 2 bond, right? Total 4. If it is 2 electron, then for 2 electron that is 1 bond, huh? For 4 electron this is basically 2 bond. Okay, so now how they are forming the bond? Like this way, oxygen and this another oxygen. Okay, so this is the way. If you make a circle also here, so this is the way we have to do. Here you notice oxygen having a double covalent bond, right? This is like this way. Okay, but other cases like hydrogen, it was single covalent bond, but here in the case of oxygen it is double covalent bond. Now we'll see for nitrogen. You see now you understood a single covalent bond also possible, double covalent bond is also possible. So is there any possibility to get a triple covalent bond? Yes, the answer is yes. So we'll see that one in case of nitrogen, right? So you see nitrogen how many electron it has total? Nitrogen having 7 electrons. So the configuration is 2 and 5. How many electron it needs to fulfill the fulfill that criteria or eligibility to get 8 electron, right? Only 3 electron it needs, huh? So both nitrogen can do these things. If we can say together they can discuss and together they can fulfill their things like their electronic configuration, right? That is what they are doing here. If you see nitrogen having 5 electrons, so 1 2 3 and 4 5. The other nitrogen you see 1 2 3 4 and 5. So now what they will do, they will form a covalent bond. Okay, form covalent bond, but that is triple covalent bond. You see here how many total electron is used? Total 6 electron is used. 6 electron means 3 bond. Okay, 4 electron means 2 bond, and 2 electron means that is 1 bond. That is what it is happening here. Now what happening? N triple bond end here. Okay, so remaining electron we can keep it like that. And you know what is this called? This is called lone pair. Okay, this is called lone pair. A lone pair means the electron it is not used in the formation, bond formation, right? That is what it is called lone pair. You can say lone electron also. So if 2 electron is there, then it is 1 lone pair, right? 1 lone pair or 2 electrons. If it is 4 like this, let's say in case of where it is happening, in case of oxygen, right? Oxygen it was total 4 electron, it is not being used. For each oxygen 4 electron not getting used, right? So those are called lone pair. This is 1 lone pair, this is 1 lone pair. So each oxygen has 2 lone pair, right? So there 4 electron is giving 2 lone pair. Lone pair we can write like that, LP. So 4 electron it is basically giving 2 lone pair for each oxygen. This oxygen also, this is 1 lone pair and this is the another lone pair. Fine. So now we have seen the formation of nitrogen. Hydrogen we saw, oxygen we saw, nitrogen we saw. Now what is the most important one? Water, right? Without water nothing is possible. Our body is made up of 70% water, is not it? So now we have to see how the water is formed. Okay, so water, the central atom is oxygen. We are in case of water, what are the atom, what are the element present here? H2O. So the central atom is oxygen here, and oxygen, you know how many total electron it has in the outermost orbital? 6 electron. So the configuration is 2 6. The 6 electron it will be here 1 2 3 4 and 5 and 6. Okay, now another thing we know from the formation of the hydrogen molecule, we saw hydrogen has 1 electron and it need only 1 electron to get the nearest noble gas. Hydrogen nearest noble gas is helium. So if hydrogen is having 2 electron, then it will stable, it is stable. Okay, So here hydrogen having one electron, the another hydrogen having the another electron, then they can have a basically covalent bond formation. How it is forming? Like this way. See, this case hydrogen having 2 electron, now oxygen having 8 electron, because previously it was 6 electron in the outermost orbital and 2 electron it got from two different hydrogen element. Okay, so it will looks like that, the water molecule formation. Now you see oxygen, that remaining 4 electron, 1 2 and 3 and 4, those are basically two lone pair. Okay, this is one lone pair, that is another lone pair. So water molecule has two lone pair. Okay, and two covalent bond it is forming with two hydrogen atom. Now we'll see the formation of ammonia. What is the formula of ammonia? This is NH3, right? So in the nitrogen molecule formation, we understood that nitrogen, the configuration is 2 5, basically 7 electron it has, and nitrogen needs 3 electron, right? And another thing, we understood that hydrogen can provide only 1 electron. So for fulfilling the 3 electron, nitrogen can accommodate 3 hydrogen, then only ammonia it can form, right? How it is happening then? Let's see. Nitrogen, this is 2 electron, and here we can give 3 electron. Now hydrogen is just can give 1 electron here. So now finally the nitrogen can form basically 3 single covalent bond with 3 hydrogen atom. Okay, so finally how it looks like, this is NH3, but that 2 electron it is not being used. As we have already discussed, the electron which is not participating in the bond formation, that is called lone pair. So here this is basically lone pair, huh? This is NH3 has 1 lone pair. So water has 2 lone pair, NH3 is having 1 lone pair. Okay, so this is the thing. So like this is the covalent molecule formations. Okay, and the ionic compound formation also we have discussed in the last class. Then what we can do next is that we can discuss some question answer from this chapter, like what are the things happening, or we can do some other molecule formation in the next class. So if you are liking the class, please do not forget to subscribe this channel. Okay, and the thing is that we are going to discuss other chapters also from this class. That will help you out, and you can write down if you have any doubt from this class, or even from any other chapter, you can write down in comment. Okay, and like if you're liking the class or like way of the teaching, please don't forget to mention here in the comment box. Thank you so much.